Yep, that's where the party's at. Number 14. Alright. 3 blocks, mass 1, 2, and 4 are connected by massless strings, one of which passes over a frictionless pulley of negligible mass as shown above. Calculate each of the following: the acceleration of the 4 kilogram block, the tension in the string that supports the 4 kilogram block, and the tension in the string connected to the 1 kilogram block. As with any problem, we start out by labeling all of our forces. Okay. Each one of these is going to have a weight. Now this is 1, and let's just use, can we use 10 for gravity? Yeah, let's just do 10 for gravity. Let's just make life, can we make life easier? You guys okay with that?
Yes.
Because it still gets us the concept. Alright, so this is 1 times 10 is 10. That would make this weight 20 newtons, and that would make this weight 40 newtons. Just making life easy. We also have to label our tensions, because clearly we have tensions. We don't have a normal force because it's not on a surface. They said frictionless, so no friction, and we're not applying anything. So that's good. So we have tension here. We're going to call this T1. We also will have tension acting down here. We'll also call that T1. Like tug of war. This mass causes that tension. Newton's third law in action. Now, up above, we also have a tension. This we'll call T2. That tension that goes over the rope is counteracted and equal but opposite to that one. So there's 2 tensions because there's 2 strings. String 1, string 2. So before I move it forward, any questions about that? No? Okay. All right, so this object is going to move which way? Which way is this going to move?
Down to the
This is going down, or that's going down?
Right side's going
Right
down.
side's going down. So the acceleration here is going to be negative. And this side's going to go up, and that means its acceleration will be positive. Now, because there's 3 masses, that means there's 3 different ones that we have to sum for. So let's do each one of those. Here, sum of our forces is equal to mass times acceleration. We have T1 acting up, the weight of the object acting down. That's equal to its mass times acceleration, and it's accelerating in a positive direction, so that's a positive mass times acceleration. We do know some of this information. T1 minus the weight of the object is equal to the mass of the object times the acceleration. Okay? That's that object. I don't know what T1 is or A, so I can't continue. Let's look at the second object, second mass. That would be this 2 kilogram mass. We sum its forces equal to mass times acceleration because its acceleration is in a positive direction, right? Mm-hmm. So upward we have T2, downward we have the weight of the object, and T1, and that's equal to its mass times acceleration. So let's plug in what we know. We know the weight, we know the mass, but we don't know the acceleration. So T2 minus 20 minus T1 is equal to 2A. I don't know T2, I don't know T1, and I don't know A. Okay. And of course, when you run out of board space, you have to erase something. So I guess we'll look at the third mass that we have, the 4 kilogram mass. Net force is mass times acceleration, but it's accelerating in a negative. So this is negative MA. Right? Very important, can completely mess up your problem. Tricky little negative signs. So sum our forces. We have T2 minus the weight equals negative MA. So T2 minus 40 equals negative 4a. Now, if I want the acceleration, I need to get rid of what? Tensions. This one has both tensions in it. This one has T1, this one has T2. If I solve this for T1, I can plug it in. If I solve this for T2, I can plug it in. And it becomes one problem. Again, we can do that. So T2 is negative 4a plus 40. And then we had the negative 20 from the formula minus all of T1. That negative is going to have to be distributed. And a lot of people leave that negative and write down 1a plus 10 and forget the parentheses. That negative is distributed to all of what it was. And so that can mess up your problem if you don't. So we now go to 4a. 40 minus 20, we all agree, is 20. This would be 1a minus 10, 2a. So let's combine some like terms. It's negative 5a. 20 minus 10 is 10. Just simplifying, right? 5a plus 2a, 7a. So a is 10 divided by 7. 1.4. Now, that's the A part. Then they want us to find the tensions of the strings. Now, you think that that would be complicated, but now you're just plugging the accelerations into the formulas. So 2t equals negative 4 times 1.4 plus 40. T1 equals 1 times 1.4 plus 10. So T1 is 11.4 newtons. And 34.4. What do you think?
Not bad.
Not too bad? Can handle that? Alright, we're going to skip a few for time. Skip 15, 16, 17, skip 18, let's do 19, 19, 20, 21, and 22, and then we're calling it. Is that good for you guys? Okay. It leaves you a few that you could practice on, which is good, but at the same time, it also, we've covered some good amount of material. We want to make sure that we cover these last ones, and then if there's questions, I'll answer them or whatever, okay? So number 19 is a circular motion kind of question. Notice that it's got a circle, and none of the ones that we have done to this point have had any of that circular motion in it, and so that's why I wanted to make sure we got these in. This is one of those multiple choice questions that would classically take you a little while if you're not as familiar with it. And so in a fairground ride, a car of mass m travels on rails around a vertical loop of effective radius r. At the top of the loop, the speed of the car is v. The car stays in contact with the rails as shown below. The acceleration of free fall is g. Which of the following is the correct expression for the force that the rails exert on the car? Let's find out.
Okay.
So our 5 types of forces. Weight. Is there a weight?
Yes.
Right? Okay, the second one is normal force. That is the force of the rails in the car. No doubt, we're looking for the normal force in our question. Right? It's frictionless. assumed to be frictionless, although we know a real roller coaster is not, and energy is dissipated, and that's why the roller coaster gets hot. No tension because there's no string, and of course we're not applying the force when it's at the top of the loop, so those are our forces. So we're going to sum our forces and set it equal to mass times acceleration. So sum our forces. Negative Fg, negative Fn, mass. What kind of acceleration? Centripetal. And our acceleration acts which direction? Classically left off the negative sign because it accelerates towards the center, which is negative direction. And a lot of people forget that, which totally gives you a completely different answer in the end. Now, since negative is in each term, in this case, they can all become positive, right? What is the force of the rails on the car? The normal force. So this is what we're looking for. So I need to subtract Fg. So which one is mv squared over r minus, that would be mass times gravity, right? So the answer is, you know it says the answer right next to it. Look at the end of the question. Look at the end of the question. It says the car, question mark. Does yours say A?
No.
Oh, well, I wrote it in mine. I wrote it down. Oh, okay. That's good. I'm glad to know that I didn't put it on your paper, but I did on mine. There's questions about circular motion. A geostationary satellite is one that orbits the Earth in an equatorial plane in the same direction of rotation as that of Earth, and with an orbital period of 24 hours. Since the period of rotation of the Earth is 24 hours, this means that the satellite is stationary relative to a point on the equator. The diagram below shows a geostationary satellite in orbit about the Earth. On the diagram, draw an arrow to show the direction of the acceleration. Here's Earth. Here's the satellite. Which way is the acceleration? Right, but only to the surface of Earth, right? Okay, because it's not going to go all the way to the center of Earth. It's going to stop at its surface. What is the name of the force that causes the satellite's acceleration? Centripetal force. Because it's a net force, right? Centripetal force. Now somebody before has said gravity, and I will say again, gravity is not a force. The force due to gravity is. The distance of the satellite from the center of the Earth is 4.2 times 10 to the 7 meters. Is that like a radius? 4.2 times 10 to the 7 meters. They gave us the time as 24 hours for rotation. Calculate the acceleration. I only know v squared over r. What do I do? Oh, the other one! Right, because there's a second formula. I see it, right? It's 4 pi squared r over t squared. So 4 pi r, 4 pi squared r. You know, I don't think we can actually put that t in there like that. 24 hours is 86,400 seconds. If you remember from our first session where we said, we probably should know. Seconds in a year? Seconds in a year, how many? It's about 3.2 times 10 to the 7. Seconds in a day, 86,400. Again, from our very first session, stuff that we would be a very good idea for us to remember, right? It does save us time. Play on words. Haha. Well, it kind of is funny if you think about it. So again, just because you don't have the velocity given to you in the problem doesn't mean you can't still answer it, right? Don't get surprised if you have a time period. And you know what? It's good to know the time frame. How long does it take for the Earth to rotate around the sun? 365 days. How long does it take for the moon to rotate around the Earth?
A day.
27 days. 24 hours?
Thank you.
What?
24 hours?
I'm so confused.
You need...
We see the moon every night.
Yeah. We see the moon every 24-hour period. Do you not? No, but you know what? Sometimes those simple things that we actually should know innately inside of us, like how long, you know, the rotation is, that we learned back like really early on in junior high. It's amazing how many people forget that. My juniors were doing a problem. They're like, I don't know how to do this, and they're like, how can I do it? I'm like, they don't give me the velocity, and I don't have the only have the radius. I said, okay, you have the radius, but what does it say? The moon rotates around the Earth. I'm thinking, you know how long that takes, and they go, well, how long does that take? No, you didn't just do that to me. No, but I realize that it is actually a lot more common, and I actually get that kind of question a lot. It's things that it's like, yeah, I should know that. I really should, but I'm not thinking that way. I'm thinking it's got to be harder than what the question's asking, and sometimes it's not harder than what the question's asking.
Physics ever easy?
It is sometimes. Didn't we just do binary to decimal? I thought that was pretty,
Yeah, and then Wiley and I were getting different numbers.
That's scary.
Yeah, I blame it on Wiley.
All right, number 21 and 22. Let's knock these two out so you can go home. A particle P is moving in a circle with uniform speed.
Yeah.
Which one of the following diagrams correctly shows the direction of the acceleration A and the velocity V of the particle at one instant of time? Yes, it's C, because the velocity should be tangent and the acceleration should be directed towards the center. Number 22, the centripetal force that causes a car to go round a bend in the road